I think we'll get going. So my name is David Fink. I'm the chairman for our BIM Copenhagen network group here in Copenhagen. I'd just like to welcome you all, especially our international guests and presenters, to our final webinar of 2021. It's been a pretty successful year, 7 webinars over the course of the year, everything from the legal aspects of BIM to digital processes. We had some demonstrations of hardware on site, seeing and a chance to play with Spot, the robot dog, see some drones, and now we're on to some LCA and machine learning. So our BIM Copenhagen group, we're a volunteer group here in Copenhagen who puts together webinars related to BIM and the latest technologies in the construction industry. And we try and do some networking as well in between. So we have a volunteer steering committee that tries to put these events together and also keeps an eye on the latest innovation in the construction industry. Our last event of the year will be a Christmas meetup at the Blue Raven on Amager. So if you have a chance, come on by and take a look at our LinkedIn group for more details about this. So we hope to see as many of you as we can. It'd be nice to see you all in person since we've just been running pretty much online all of 2021. So I'd like to say just a quick thank you to our sponsors, Zealand, Zublin, Room, Big Art Architects, Architima, 3D Buggery, MS Communication, NCC, Blocks Hub, and Alex Paulson Architects. So today's event is early stage tools for embodied carbon assessment, where we'll be seeing some of the latest innovation on how you can calculate LCA from this great team. But before I hand it over to Kritika and her gang, I would like to just have Jakob say a few words about the rules of the webinar today.
Thank you, David. As normally, if you have followed us before, I will take responsibility of the webinar's technical part. So if you have question and answer or something, just use the Q&A down in the bottom of the screen or the chat menu. I will collect all the questions, and then we will ask them in the end of the webinar. So only if it's very critical, I will interrupt the webinar. So when you ask, I will actually ask you to ask directly to the speakers afterwards. So I will let you in and give you speak rights. So you have the possibility to that. So the speakers won't look at the chat and the Q&A at the while they are speaking. So over to you, Kritika.
Awesome, thank you. Just share my screen super quickly. Yeah. So firstly, thanks David and Jakob and the whole team at BIM Copenhagen for having us. I'm Kritika, and today I have my whole team here. We'll be presenting 2 different set of tools that are completely different yet same. The first one, Learn Carbon, was done within 30 hours as part of the AEC hackathon recently held at Blocks Hub, and the team consisted of the names which are written here. And the second one is a more prolonged tool that we have developed over the span of past 6 to 8 months. It's called Cardinal LCA. You would have seen a lot of posts about it on LinkedIn if you are very much into LCA, and if not, we'll give you a brief intro about what it is and what we have been doing as part of these 2 tools. So to start off with, we say that both of these are early stage tool, and that's what the topic of this presentation was. But how early are we thinking of? And that's where we decided to bring both of these tools in for this week's presentation, because Learn Carbon is more a Rhino plugin, which is at week 1. So at the time when you start building your energy, like your building massing, when the project is just given to you. And Cardinal LCA comes in when the project is a bit developed, but not that developed to be in design development stage. It's more still in the conceptual design stage or the competition stages. And now I'll hand it over to my colleague, Panayota, who will walk you through what Learn Carbon is all about.
Thank you. Share. Yes. So thank you for having us today. I'm Panayota. What initiated our work is the fact that embodied carbon emissions are increasing day by day. And from research about future constructions, we can see that embodied carbon emissions will be 14% more than operational carbon emissions already by 2040. Additionally to that, the opportunity to change environmental impacts by replacing materials gets harder as a project develops. And as we can see in the graph here, such changes can change a project's budget severely. As a solution to this, we suggest empowering architects to take sustainable decisions from early design stages of a project. And in order to do that, we created Learn Carbon, which is a Rhino plugin that integrates two machine learning models. The first one inputs a conceptual massing model from Rhino and then extracts data about the area of the building, the total buildup, and its structure type. And then it predicts the global warming potential of the building in a 50-year lifespan. While in addition to that, the second model building gets us an input, the conceptual massing model, which means area total buildup, and then we target a global warming potential value, and then the machine learning model predicts a suitable construction structure type for it. As you can see here on the left, here is the plugin that we created in Hackathon last month. And now Iliana, my colleague, she will introduce you to the methodology and how we actually build that thing this weekend.
Hi everyone, I will also share my screen. I'm Iliana, and I will continue with the more technical side of things, and specifically with the methodology. So at first we use the embodied carbon benchmark dataset, and the problem was that the data were categorical. So for example, the floors was 1 to 3 floors instead of a specific number, and we needed a specific number for the task we have targeted. So we transformed it based on the carbon emissions. So we examined the range for each category, and then we distributed to how many floors each one should be, or also the area, the total area of the building. And then we also augmented the data set based on the structure types, based on the research, of that. Specifically, our data, this is a distribution of our data, graphs about the distribution, and we can see that there are biases towards smaller buildings with less carbon emissions, and that is something we will discuss in the future work as well, the further augmentation of the data. But as we can see in this graph, the correlations between the different features are not that high. So we can actually have a model that learns this relationship between the inputs and the outputs. And then for the training, we use Google Colab with TensorFlow and Keras to build the two models. The first model is regression because it predicts one value, the carbon emissions. And as we can see in the graphs, this is the loss graph. The model can actually learn. The dataset was split into train and test. So the testing was also from the same dataset. But we will see the videos of different examples and in the demo. And here in this graph, we can also see, which is the ground truth and the predictions, we can see that it's actually kind of learning. And here is the second model, which is classification, classifying between different structure types. And here are the predictions in the true label, and we can see that most of them are in the correct axis. So for the next part of the methodology, I will pass it to Karim to explain the link to Grasshopper Rhino.
You guys hear me okay? Maybe a thumbs up from someone.
Yes.
Sounds perfect.
Great, thank you. Cool, thank you, Ilyana. So right now the challenge essentially was to connect everything together. Natively, all this technology doesn't communicate with each other. And of course, given the fact that we are writing everything in TensorFlow in CPython, we needed essentially to figure out a way for Rhino to look at the trained model in real time, and for the user to be able to fetch the predictions that a server essentially would serve to you in real time, so that it's actually this interaction of the user and the prediction would be in real time. And there would be also this kind of synthetic feedback going back and forth. So what we had to do was essentially build a Rhino interface using kind of like the .NET framework. And so that's what you would see on the left here. Essentially, it's just kind of like a heads up display where you would select the model, put in a few data points about the floor to floor height, whether it's a commercial or residential building, the region that this building would be built in, and also what the actual structural type is. And then you would hit calculate, and as simple as that, it would serve that prediction of that model. So that's kind of, let's say, the front end. And in terms of the back end, what's interesting is that Rhino has been doing a lot of open source development lately that we've leveraged in this case. Namely, the hops technology has been really helpful here because it just broke the barrier between the classic IronPython.NET ecosystem that's quite opaque to other libraries to the CPython, like let's say Future, which allows you to talk to any kind of library, in this case being, of course, a TensorFlow and all its peripheral dependencies. And so in terms of how it's set up, it's actually very simple. Using the kind of like the decorator pattern of Python, you can essentially just decorate a function that would call a machine learning model into a hops component. Once you have that, you essentially have a native Grasshopper or Rhino entity that you can talk to live. The only thing that you need to do is, in this case, it's run on a Flask server. So you would have to deploy a Flask server, and then that would be that live link that you could essentially ping that server, and that server would serve you that those predictions in real time, as you can see in the demo here. So you would, hit all your parameters and then hit calculate, and then as you can see on the left, the server is being pinged and the information is being retrieved, and this is in real time. So that would be model A, which would be the desired output would be the global warming potential being predicted. And model B, this is what my colleague was mentioning, that we have also created two separate machine learning models. And this is the one where you would predict the structural type given a desired global warming potential. Again, the nice thing about this technology is it's simple. It's simple and very modular. So depending on what kind of predictions we want, we can, or what kind of prediction types, let's say, we can easily adapt this for that purpose, since the entire code is very modular. And it's, again, using this Flask ecosystem with Rhino Compute over a local server in this case. And the potentials of this are very, very, very good, because you have a road forward for scaling. You can have this server not be run in your machine, but actually be hosted somewhere else, whether it be AWS or on an on-premises server. And then everyone could be talking to that server at the same time and getting their predictions, which has a whole swath of implications in terms of increasing the data set in real time and making the data set better, and also just sharing data sets. So that's extremely exciting. And yeah, so this is kind of a demo in that sense. So of course, let's say the more holistic goal would just essentially be to bring lifecycle assessment and carbon literacy or transparency to the designer. As mentioned again by my colleague, the impact that you would have in the beginning of a design, let's say routine, is much higher than in later phases. So an obvious solution would be to bring this complex information to users at an early stage. Of course, calculating all these things, all these dependencies, and all the phases in a typical life cycle assessment is a very difficult thing. And there's a lot of people trying to solve that with very smart technical solutions. What we're doing is we're trying to reduce that complexity and just serve, again, the user with the necessary information that they would need in real time without them necessarily having to actually go in and take all the measurements and calculate all the embodied carbon themselves. We're relying on a bigger data set and a bigger community of carbon transparency. And it seems like this is also the way things are going to be going. Also right now, a lot of certifications, a lot of tools are embedding these kind of technologies and these kind of concerns in terms of carbon and LCA. And so it's, in terms of its placement in the, let's say, the zeitgeist of what's going on in the AEC industry, it's very well placed. And right now we are looking specifically at phases A and phases B in the life cycle assessment, because that's, let's say, what the data has shown to us. Of course, this can extend to all phases. It's just a basically matter of how much data we have and how much reliable data we can construct or enhance and synthesize. Of course, this whole project was done in 24 hours, 30 hours or something. And so there are obvious limitations to it. This is a proof of concept, let's say. Again, data with any kind of machine learning endeavor, data is the building block. The better the data, the better the product. And so that would be, let's say, the first priority is to actually enhance the data and get more of it. Right now, we're also just suggestively saying what the structural principles are and what they could potentially be predicted to be. We could go into more detail there in terms of spans, in terms of structural type, like actual structural designs and types. In terms of how LCA is being calculated, there's a lot of disparity between different countries and different regions and how that gets calculated. And so managing that in terms of all the EPDs and where or how carbon is being actually measured will be a challenge. And then, of course, on a technical level, the dependencies of the plugin. Right now, there's a few dependencies that maybe each user might not have natively. And so a solution to that would be also on the technical side, on the back end would be, let's say, the first thing to do to just make this kind of a plug and play solution. So, which leads me good to the future work. Again, we can integrate, like I mentioned, the structural layouts, spans, structural types, etc. We could potentially start predicting other things like material quantities of the structure. Again, given as much data as we have, we can predict all these kind of detailed things, which gets very exciting. We could start to also document as we're working, which is the beauty of this. Now you can start to measure carbon, do your predictions, calculate LCA, and then also, let's say, measure the accuracy of that, and then feed it back into the data set and increase that. Of course, that is that's a bigger discussion of how that actually gets done. But there's a lot of potential with the data enhancement in that sense. And of course, in terms of, let's say, accessibility, everything's moving to the web. And so we're still, loyal to Rhino, Revit, and BIM and that entire ecosystem, but developing a platform where it's a little bit more software agnostic, I guess, where you would just be dealing with data types and prediction of those data types. And then that could be served again to whatever software suite you desire. In addition, could be hosted on a web platform of some kind, which makes it the most accessible and the most easy way to, let's say, send and receive data and solutions and designs. This is our team. 4 of us were here in Copenhagen, working away. 2 of us were remote, Harry and Anirudh. And yeah, came together very quickly, and we're quite proud of the actual result, both in terms of the fidelity, the design. Also, the UI design is, I think, very intuitive, and also the workflow is, let's say, pretty clear in terms of how it works. And the beauty about it is it has a very simple technology behind it that will scale pretty easily, in my opinion. Yeah, and these are just the acknowledgements. McNeil, Carbon Leadership Forum, of course, Henning Larsen, Big, Gabriella from CETA, and yeah, that's kind of my part. I guess I would hand it over to Kritika at this point, or maybe someone else, I'm not sure.
Thanks, Karim. So as my colleagues already explained, that we know that the ratio of embodied carbon to operational level is changing. If we look at this graph, that's just from Architecture 2030, we see that in a build as usual scenario from 2020 to say 2030, the percentage of embodied carbon would be still 74% because of the upfront carbon which comes up because of all the construction. And if we look at 30 years down the lane after the building has been constructed, it would still be constituting 49%. So it's a huge, huge amount. And that's why we decided to build Learn Carbon, which is like super preliminary tool. So when an architect is doing basic piece, it can help you predict. But of course, as some of the comments are, that it's not very precise, and the quality depends on the quality of data. The quality of prediction depends on the quality of data that we have. And again, I'd like to point out that that was built within 30 years. So we see that there is a huge potential in developing it if we are able to get the data. And now we'll move on to Cardinal LCA. So that comes in at a later stage, like the next stage of the project. So when, say, the design is developed and the architects are running simulations on daylight, structural analysis, operational carbon, utility costs, that might be in the concept or design development stage, but also in comparisons, because most of the firms are doing these simulations in the early stages itself. And this is where we believe that we need to take into account the embodied carbon studies as well. But we understand that there is a lot of flexibility because the materials are not decided, and LCA is a tedious process because we don't have any clarity on the kind of materials we will be using. That's why we decided to make a tool which is in a good balance between precision and ease of use. So it still gives you some sort of information on where or what kind of materials you can use. It's good for benchmarking, and it's a good tool to guide you for the concept design phases. So you would know roughly what your project's GWP potential, like a global warming potential, would be, or it can just be for a simple wall or the whole building calculation. So this tool has been developed as part of Harvard GST. It was started off as a simple project between me and my colleague Jessica, who could not be here because she's in the US right now, and she's not a superhuman like Karim is. We have been developing it as a venture and a research project in collaboration with the Harvard Innovation Labs and the National Science Foundation in the US. And we have received some grants in order to develop that and also check customer validation and all of that. So this is Cardinal version 0.0.0. So this is what it looked like when we submitted the project as a final project stage. It was a Grasshopper maze. Nothing was organized. We had tons of interdependent components working together. And I just have a video of, you all would recognize this. This is using Human UI. It's a plugin that helps you develop an artificial UI. And we had a lot of these different parameters and inputs. So this was more responding to a parametric model that the users can have in the Grasshopper itself. It was linked together with Ladybug and Honeybee, so it helped you identify an EPW file in order to do the energy calculations. And then we were using ICE 2019 data, which is catering to the UK in order to do the embodied carbon calculations in this one. And yeah, then it basically gave you some graphs on both embodied carbon, but also operational carbon. We also had a feature that helped run the structural analysis and optimize it using some basic multiple objective optimization tools in Grasshopper itself. So we compared this with Athena Impact Estimator, and we found the results to be quite similar, because you see that in here, a glass is the maximum contributor, and in Athena, which is the walls or the envelopes which incorporated the glass, was the front runner. And then we had the slabs, which is the project extra material as the forerunners, and then beams and columns that come in third. So we decided that maybe we should take it further. We got good support from both the school, but also several external people who saw the presentation. And then we formed a team, which Hari and Anirudh are part of. We are 5 now. And we developed the Grasshopper plugin, which was super simple. It consolidated the whole Grasshopper maze into 4 very simple steps. So what you have to do first is basically import all the geometry which is already existing in your Rhino model. It can be done directly through Grasshopper if you have a parametric model. If not, we have a component that reads the layers directly from Rhino. So you just have to feed in the names. For example, in this case, we want to measure what wooden lamella consists of, and then we just write in the name. Another option, yeah, and then it basically gives you data on the total areas, the number of B reps, and the layer geometry. If it's not a poly surface, then it also has an option, like you have an option of adding a thickness. So if your model is not at the stage where it's been developed with all the precision and you have no idea of a thickness, you can add a thickness manually and it will still work. For example, in this case, we have some stone panels, say on the facade, but we did not know what the default, like what the units would be. So we just added a dummy value in order for the tool to do this calculation. In terms of material selection, which is the second stage, we right now have in the Grasshopper plugin, we have 2 material sets, which is the EC3 database from Carbon Leadership Forum in the US. And then we have the ICE 2019, the UK database, as was in the original version as well. So if you just select the material type, you have different categories that the information is based upon: submaterial name, GWP, density, location, etc. In terms of EC3, we have 2 values. One is more specific, that gives you information on specific EPDs. But if you're not sure and you just want to do a comparison between, say, aluminium, steel, wood, then you can also go for average values. And these are the data which are directly taken from EC3. So they already have all that data processed and we're just calling it in. In EC3, we have an option of several filters. So you can select the regions. We understand that it's mostly for the US, so they don't have a lot of data for other regions right now, but we are working together with them on A4 and A5 stages, and they plan to expand it further. Yeah. And then another feature which makes it usable for everyone else who is not located in US or UK is that you can add your own data from any EPD, which is pertaining to your region. So you just have to feed in these values on name, category, subcategory, GWP, etc. And then we have a component that saves all that data into a local file for you. So this is where the materials will be saved, and you don't have to save again and again. You can just call this file directly in the next model that you would want to test in. And the last is merging all the information you have together and then feeding it more into a report format. that helps you read all the information that you've put in. It allows you to export an Excel file, but for those who just want to see the results in real time, it has all the information there on which layer has the most GWP or which material has the most GWP. And then you can keep changing things and it'll update in real time, which is the flexibility that most other LCA tools lack. And then we have an option of outputting some graphs as well, because that's what most clients or even architects understand. We know that these are not super beautiful, but it's more to convey the information at the moment. So you just put in a base point. It's similar to how most graphs in Grasshopper plugins work. And then feed in all the values that you have from this one main component, which is the report component. And you can feed in information on height, width, division, customize the graph based on what scale you want the graph to be in. And it shows you, you can also put in colors on low bound to high bound. Right now it's say green to extreme red, and it shows you the impact that each layer has, but also each material subcategory has. So there are two ways. So this is the 2D outputs, but apart from that, we also have a 3D mapping directly onto the Rhino model, which is something new. So if say you just want to talk with your architect or say client and show them that this is where most global warming potential lies in this particular geometry. So you have the option of mapping it onto the 3D model and show it directly when the colors change from say red to green. Yeah, and it's called color BREP. Right now it doesn't have an option of you can bake it, but it doesn't have any outputs as such, and therefore like we would love for you to try it out and give us any feedback on what you think can make it better, or if you want some sort of additional dependencies on how to translate this information better, so you can talk with the clients or with the architects for that matter. Yeah. Okay, yeah, and this is just a demo that we did at Henning Larsen itself. We were working with this facade assemblies and we had to make some comparisons. So we see that it takes in that geometry, it takes in the thickness based on what the element would be once you change the material, and then it gives you outputs in real time. So we understand that it's not 100% precise, but it gives you some sort of indication on which direction to go for at this stage. And that's what this tool is all about. And for what next, I'll hand it over to my colleague, Hari, who's been developing this wonderful Rhino plugin.
Thank you, Kritika. Yeah, so myself, Hari Prasad, I was part of the development team for both Cardinal and Cardinal LCA. So the goal of Cardinal is to bring early stage LCA calculation to everyone. So as a part of this, we have decided to make a Rhino plugin for non-Grasshopper users. So we have created a plugin using .NET WPF, and this plugin is still under development. So here you can find the demo video of the plugin. So in the home page, user can fill in the project information, and in the input page, you will find all the layers that are present in the Rhino as a panel in this plugin. So user can fill in select the material space for each layers. So we have EC3 specific, average, and ICE database, and also you have the custom and saved databases. So in the top, you can find the path to locate the saved materials where user can choose the saved materials. And here, whichever layer is used, you can select the material for that particular layer alone. And after selection of all the make button, so the output will be generated in the output page. In the output page, you can find the graphs and the detailed report summary of this calculations. And we are planning to release the tool by January 2022. Yeah. And here you can see that you can fill in the custom material details and the output page. Here is the page. Yeah.
Thanks, Sari. So now is the time to let us know what you want in the Rhino plugin. Yeah, and we are also developing our own API, and I'll hand it over to Anirudh, who's been working heavily on that.
Thank you so much, Kritika. I hope I'm audible. Okay, so for LCA calculation in Cardinal LCA's plugin, we would require some legitimate data from different sources, which would be relevant to maybe the manufacturing and impact related information for the building materials. According to our research, we have recognized a couple of databases, and there are some challenges which we are looking forward to working on. Firstly, I would like to mention that there would be a need for a centralized system where we can pull data from different databases according to a predefined structure that we will be using in our plugin. So to achieve this, we have initiated a process of a centralized API development, which you can have a look at this screenshot that we have added in the presentation. This pulls data from different databases and categorizes it into 4 headers, namely the manufacturer, impact, data item, and the general one, which comprises the combination of all the different 3 headers. Currently, we have worked on integrating EPD Notch and Okobota databases. Talking about databases, we have very limited EPD data, which covers very few countries, and the structure, the format of data in each of these, as well as the future databases that we are going to use, are completely different from each other. This will require us to standardize according to a specific structure that we are going to use for our plugin. In some databases, luckily, the data is structured into tables, but we have recognized a couple of them which have in PDF formats as well. We are working on bringing all the different forms of digitized and non-digitized data into one digitized form. And having a centralized API system linked to the original database, which gets updated frequently, we try to achieve the dynamism of our plugin when it accesses the fresh data. We also look forward to building an authentication system that will control the data access given to different users and super users. Finally, we are working on building a user-friendly front-end for the API, where users can log in and view the integrated system that we will be releasing. Over to you, Kritika.
Thanks, Anirudh. And I would just like to say again that without this amazing team, none of it would have been possible. So a huge shout out and thanks to them. Yeah, and lastly, we also have received a research grant from Harvard Office for Sustainability, wherein I saw this comment on chats that it all depends on the data, and that's what we will be working on. So we are about to collect construction assembly data on both the whole building LCA, but also as built drawings. And we aim to incorporate something like a construction assembly in the Rhino plugin that informs the architects on what kind of assemblies they can go for and what the red flags in that construction assembly are. So for example, if they end up changing, say, an insulation from this one to the other one, can they save some GWP, or how to guide them? So this basically shall help them predict and guide them on some bad conventional and best practices. For now, we have the grant only to collect the data for the US, but if given the opportunity, we would love to work more in this field and make a standardized data set that is open source and easy to use for everyone. And that brings us to the end of our presentation. This is a snapshot from the Food for Rhino page where the plugin is located. It's free. Please download it. We've had 264 downloads so far, and a lot of people have written back to us with some good and bad feedback. All feedback is welcome. So yeah, you can also scan this QR code and it leads you to that page. So thank you so much again, David and Jakob and everyone else. And yeah, over to you, David.
Thanks for the fantastic presentation. I think we'll open it up for questions now, and we'll have Jakob. He'll be moderating the questions from his side.
Yeah. I've got a few questions. I think Ross, your question was talked about right at the end. So I will ask Roger if you want to address your question. You just have to find you in a list. Ross, you have still you can have the word, Ross.
Unmute. Thanks, Jacob. Roger is actually a colleague of mine, but I think he had to jump off. Very interesting presentation, guys. It's really super. My background is in cost management, and the biggest challenges for us are in the earlier stages when we need to benchmark costs, and the same questions are being asked of us now from our clients when we need to benchmark carbon. So in terms of BIM, we're fully kind of connected with the 3D models and the development of the design material, but a lot of the questions relate to the earlier stages before we have any design material. How do you see that happening in relation to carbon, and have you guys discussed that internally?
I think I can answer this, but basically what we do in Rhino, in the input, we translate the model into numbers. So numbers that describe the model. That's how the model learned as well. So if we had these numbers, for example, the number of floors, the total area, and the footprint, we could, of course, the location and the type of building.
Yeah, for sure. Yeah.
We could have a prediction out of that.
Okay.
So it could be outside of the Rhino model, and that refers back to what Karim was talking about, information flow and software independency. So if we reach that level, it would be very interesting to see in what other environments we can use it. For example, Excel, just Excel.
Super. Okay, thank you very much for that.
Perfect. Then Nima has a question, a little more technical, I think. Nima, would you like to ask a question?
Yeah, sure. It already has been answered actually by I think Anirudh's foil. I was thinking about the databases that are being used, especially about Ökobaudat. So I saw that in development, so that has been answered. But another thing that would interest me is since you're always, or most of the time, are concentrating on the structural impact, if you thought about using safety values or factors to integrate the later design regarding facade, maybe even MEP installation and all that.
Yeah, I can take that one. So we would have loved to incorporate some sort of structural analysis, or maybe just predictions or guidance on structure. We are working towards it, but we don't have a structural specialist on board who can guide us with, say, the basic principles that go behind defining all such things. The thought process behind Learn Carbon was also to move in that direction, or have some sort of structural prediction as well. And that is definitely one of the goals in the near future, but we don't have that for now. And we would love any sort of collaboration that helps us incorporate that.
Okay.
Thank you, Nima. Then I think, Kritika, you talked about how to get hands on these softwares. You talked about the last one, the Cardinal one. Is there a possibility for the listeners to get the first one you talked about?
Yeah, Karim, would you like?
Sure. Right now, you can use it if you have a Rhino license. That's the limitation in that sense. And there's a dependency package that we've also documented, which with a quick procedure you could also install it. And I've done that on a couple machines or a couple people already online, so that's not an issue. I will say that the priority right now is to package it in a way that it's autonomous on Yak. So basically that within the Rhino package manager, you just download it there and you never have to talk to us. That would be the next thing. Yeah.
But for now, it's
to
on
answer your
GitHub.
question, yes.
Just to mention that there is a link to GitHub from our website if you want to find it.
Yeah, that's on the. Everything is there. You can clone the entire repository. The README, it still needs work in terms of actually, documenting the setup and all that. Yeah, but that's all to come.
I'll just copy Katrika's links to the menu so everybody can see it. I think you have only sent it to the hosts. So I'll just do that afterwards. David, I think that was the last question I have written down. Is there a last one? Then raise your hand, or else I will let it go to you, David.
So just once again, a huge thanks to Kritika, Kareem, Ileana, Panatoya, Hari, and Anwar. And thanks for Kareem for waking up so early to join us today. It's really appreciated. Really a fantastic presentation. So we'll have this recording available on our YouTube channel in a couple of weeks. And in the meantime, you can keep an eye on the next events on our LinkedIn page, which you've found this event invitation on. And hopefully we'll all see you on the 9th at the Blue Raven on Amar. So thanks for joining, and thanks for helping us end a fantastic year. So we'll be in touch.
Thank you for having us.
Thank you.
Thank you very
so
much.
much.